This film presents the activities carried out in the Under Ice 2014 field experiment in the Fram Strait. The main goal of the experiment was to deploy 8 moorings for acoustic and oceanographic monitoring of the ocean environment.
The aim of this project is to set out acoustic network to measure the ocean temperature in the Fram Strait. And then the next is to set out 3 oceanographic moorings which will support the acoustic network. The 3 oceanographic moorings are deployed for the NICE project led by Ilke Fair at the University in Bergen. Each mooring carry a large number of oceanographic instruments to measure temperature, salinity and pressure at selected depths from near surface and down to the seafloor. The moorings are also equipped with acoustic instruments to measure the ocean current profile. We also have some recoveries or moorings for Alfred Wegener Institute, and then to do XPT and XCTD measurements to support the interpretation of the acoustic measurements.
The instrument here is an ADCP, acoustic Doppler current profiler. So it sends out a sound signal, and using the Doppler shift in the sound, you can then calculate how fast the water was moving.
Yeah, those are going to be mooring anchors. You have a release on top of it, so you'll never recover the anchor. It's just something that stays on the seafloor.
These are flotation balls. These are glass balls inside these yellow hard hats. And they provide flotation for the mooring, so it stays taut.
Loading the big floats, the big sources, all the anchors, getting all the big pieces on. And then this afternoon we'll bring out all the small boxes that we can carry by hand that will go into the hangar and down into the lab.
Before we go out with the ship, we have to test and program all the instruments. We decided to bring more engineers to help with the preparation.
That's measuring the weight of the instrument just by the load pulling down on the crane. The air weight is critical because on launch all the deck equipment feels the load by the air weight. But once it's in the water, the buoyancy of the water decreases the load. But you have to design the mooring to support that amount of weight underwater.
It's going fine. Everyone is working hard, so we are almost done now. And we are discussing several options for deployments. We have two major plans, one plan A and one plan B. And the ice is not on our side, so we have problems.
Plan A was the original orientation geometry of the acoustic moorings. And again, you have to know beforehand where they're going, what the travel times are, so all the instruments are coordinated and do the right thing at the right time. And it looks like there's kind of more ice than they thought. So Peter and Hanne came up with Plan B, which is a different geometry that's much more likely to occur if the ice conditions are bad.
Well, it's great to get started. We're all very excited about deploying the moorings and recovering the moorings. So it's a good feeling to get into the sea and also into the sea ice.
Welcome on board, and I hope that the cruise will be just as good as the mobilization was.
When we came out in the beginning of the cruise, we had to make a decision, and we decided for Plan B. As soon as you have a plan, you have been thinking through what you are doing, and then it's much more easy to make changes because you know what it will influence.
You have to be careful here. No it's a recovery of the mooring that's called PP27. We deployed this mooring last year from Polarstern, and we've been here this June, but we were not able to recover this mooring due to the ice conditions. So it's fine that we have a second try now.
Picking up a mooring is basically we have acoustic releases that are down on the anchor, and we send a signal from the ship down to the releases, and which tells them to basically open. And once the release is open, it lets the whole mooring come up to the surface with the buoy on the top. Once the buoy's up on the surface, we'll go into a recovery mode where we'll hook in a winch leader into the buoy, and then we start hauling in all the equipment. Yeah, we secure the instruments, and basically it's kind of a hand-over-hand motion, if you will, of pulling in the mooring.
Today we're going to be deploying the first mooring that has an acoustic source on it.
We are doing a test sweep with the source at the moment, and in the air we're only running it with 10% power. So that's why it's hard to hear it with the ship noise around, and therefore you just put your hand on where the sound is produced and you can feel the vibrations of it.
This source will transmit to receivers on the other moorings. We want to get this in first to make sure we have a working source in the ocean before we deploy the receiver moorings.
So this is one of 50 hydrophone models we will deploy during the next weeks. And in total we have 5 moorings, and on each mooring we'll mount 10 of these hydrophones.
So far so good. So nearly all wire is in the water now, so there are some small pieces left, and then we will get the buoyancy, the yellow balls in the water, and then releasers and the anchor, and that will be it.
We've pre-selected positions for all of the moorings because there's a specific time, travel time from one mooring to the next, so they all have to be in the same geometry. And what we do when we deploy, where we drop the anchor last, is we start, I think, 4 miles downwind, and we steam upwind as we pay out the mooring. And then the goal is to drop the anchor close to the position that we want the mooring to be at.
It went good. Mooring's in, and we're gonna probably be doing transponders this evening. So mooring's complete.
So you have to be patient in this game, because now it takes at least 1 year before we learn anything, because the data will be in the water. It will be stored inside the instruments in the water. But for the main story, we have to wait another year. So it will take 2 years before we get benefit from most of the data.
We were a little bit slow, and so we actually dropped the anchor 200 or 300 meters past the drop point. But that's easily within the acceptable air radius. We could have been off a couple of kilometers and been fine. You know, we actually sent out a small boat with a listening device and verified that the source, in fact, was transmitting quite clearly. So everything looks good. And today we'll go around and put in small instruments. It will just be a couple of meters above the seafloor that we'll use to position the mooring as it moves in response to the ocean currents. So we need to know where it is to within a meter or so in order to get accurate travel time measurements.
We want to make sure that the source is working, and therefore we drove away from the ship to be away from the noise of the ship.
Lazarus danser I Bergenhavn, danser en glad lystig dans.
So we will lower now the hydrophone. It goes down to a depth of around 100 meters. And we will now start recording, and we hope that we get the signal from the acoustic source. Okay, we have the data recorded, and now we will bring up the hydrophone.
A significant part of our time on this cruise is spent bundling up different kinds of cable.
Lazarus sitter I ethvert lem, men av falsker en damen I dette poem finnes knapt kors på min hals. Lazarus blir med till kvinnens hus bakom hotell Rosenkrantz. Lazarus svävar av sted som i rus, brännhett är öjets glans.
Okay, we're back now from the little boat on the ship, and we are analyzing the data, and we're looking for the signal of the source, and we have clearly found the signal. This is a spectrogram where we have frequency versus time, and here we have the 90-second signal of the source, starting with a lower frequency and going to a higher frequency.
For maken til damen i denne balladen unngår du ikke sant, sant.
We would like to have a very accurate position of the source, so therefore we put 4 transponders around the mooring.
Those are tiny buoys sitting on the ocean floor, and they are positioning the mooring at all times. So they are communicating with our main mooring that might be swaying back and forth.
Okay, Jonas, start down.
And from the time it takes to communicate back and forth between them, the mooring can calculate where it is.
They only communicate with the source, so the source sends the ping and the transponder answers the ping from the source, but they do not exchange information between them.
Transponder away.
You know, we're at the site of a mooring we call UI4, and it's over on the western side of Fram Strait where there's quite a bit of ice. And normally under these conditions, one would like to put the anchor in first and then lower the mooring vertically so that the anchor just keeps the mooring vertical behind the ship so it can't get tangled in any ice. If you do anchor last, you have to steam the ship ahead while you pay out the parts of the mooring, so there's the danger that the float and the other mooring components could get caught on an ice floe, and tensions could get very high and you could part the mooring. So it's kind of a dilemma. You'd normally like to do an anchor first under these conditions, but our equipment isn't quite suitable for that. So we're going to do some tests this morning to see if it's adequate.
Yeah, we go for anchor first, and we are fine with that. It will be exciting since it's the first time we do that. So this will be a new experience for us on board here.
Is the radar. You can see the yellow dots here showing the ice around us.
But that is the standard method that they use at the Alfred Wegener Institute and also University in Bergen. So it's not an uncommon method in ice. That's the standard.
It's very beautiful out here. It's hard to see it shrink so fast during the last years and during the last decades.
The main issue, I think, in last decades, which is the main focus of most of Arctic science and Arctic research, is the strong link of the Arctic region to the world climate, especially in the context of what is commonly called climate change.
More ice-free areas showing up, and that increases the impact of the heating from the sun to the water masses below, and that can start dynamic processes.
So the processes which we observe in the Arctic, or in generally called northern polar region, they have very strong impact on the climate of the whole northern hemisphere.
The moorings that we put in for the Nansen Center included 2 acoustic source moorings, 2 moorings with acoustic sources at a few hundred meters depth, and then 3 moorings that had receivers on them. And each of the sources transmitted to all of the receivers, including a receiver on the other source. So there were a total of 8 paths from each source to the 4 other moorings. And these will be measuring over the next 2 years the average temperature in between all those moorings.
So the second source is working, and yeah, we're now about to deploy the oceanographic moorings. Now we have a new type of rope, and we have some troubles with it because it doesn't have a coat, and it's very slippery, so we can't get enough friction on the winch.
With this line on this winch, it's impossible to do the deployment. It's too slippery. It won't hold the load. So the solution is going to be we're going to have to do these moorings anchor last so that we don't have such high loads, which means we have to find relatively open water in order to do the deployments.
The moorings we are deploying today is to have a control over the flow of warm water into the Arctic Ocean. And then we will monitor it for 1 year, and particularly we will look for mixing in that current. So we see how the heat is distributed also vertically in the water column.
So it begins. I was thinking those exact words before. We have sensors that measure temperature, conductivity and depth or pressure, and from that you can tell, apart from the temperature and the salinity of the water, you can also calculate the density, for example, of the water. And then we have current meters, both current meters that measure in one specific point and current profilers that measure over several hundred meters of the water column.
It's going perfect, just as planned. So everything looks good. We are very good weather conditions, as you can see. There is no wind and no waves. This is a unique experiment. We never did such a detailed study, and with all this fancy equipment as we have today. We are actually covering the whole water column from 25 meters depth down to the bottom at 1,500 meters depth, packed with instruments all the way.
Well, that's a relief. All 3 oceanographic moorings in the water, and all of the acoustic moorings as well. So that's great.
It was a great relief for us to get rid of all those buoys. When they disappear, it's a beautiful moment.
True, true.
Just went down to check everything is okay on the hull. All the sink is on, and just looking for any damage at all after all the ice breaking.
It's the only icebreaker we actually have in Norway, so we are specially designed to operate in this area, in these waters. So Spitsbergen is our area of operation. We are a nation of seafarers and scientists, actually. Well, it's a good tradition, I feel, and it's an important work. Manson was one of our heroes in the Arctic and Antarctic, so it's nice to follow his footsteps. But having scientists on board is actually very interesting, because it's kind of a different operation from what we usually do, and it's nice to see how they work and operate.
It's always nice coming over the ice. The light is very good, but you couldn't see so far today, so it was a bit different. And, it's nice to have this kind of practice. No mermaids, no, and no polar bears, thank God.
We are now between our 2 northernmost stations, UI4 and UI5. One of them is a source and a receiver. We have deployed both of them. And during deployment we were always going south and around the ice. Now we are going straight through the ice because we want to make measurements on the direct path in between those 2 stations. That is the way our acoustic sound will travel, and we want to measure temperature and salinity along that path to calculate the exact sound environment during the time when we are measuring it.
The equipment that we recovered for the Alfred Wegener Institute included one mooring that had a near-surface profiler. This is the package that has a subsurface float that's something like 50 meters below the surface, and then a small package that's winched up and down to measure the very near surface layers of the ocean, a very hard part of the ocean to measure. So this is a small package that gets winched up and down to measure temperature, salinity of the ocean in those upper layers. The other instrument we recovered was a bottom lander. It's an instrument that sits on the seafloor, and it included some biological measurements. There were actually little probes that penetrated into the sediment that had some artificial sediment and nutrients in them. And the goal was to have microscopic creatures, nematodes, that live in the sediment, basically be attracted to that artificial sediment and the nutrients in there so that they could bring them back to study. So when we recovered it, all of those probes sealed and trapped the sediment and the organisms that had come to inhabit it while it was sitting on the seafloor. Oh, after we had finished the other work, we went back to try to recover the third and final mooring that the Alfred Wegener Institute had in. But after beating through the ice for quite a few hours, it turned out there was just too much ice in the way and we couldn't recover the mooring.
Today we weren't able to recover our last mooring because of the bad ice conditions. So the ice was completely packed and it was not possible to get an open spot into the ice.
The final thing we did after that, the first mooring we deployed, UI-1, was a receiver mooring that transmits short pings to the bottom transponders every 3 hours. And we hadn't actually verified up to that point that it was transmitting those pings. So the final thing we did was stop and listen to it and make sure that it was transmitting, which essentially means that it was working. The clock and the instruments working, the computer's running. It means the odds are that everything's just fine. And we, in fact, heard one ping and we're done. That's all it takes.
So we're happy that we could deploy all 8 moorings. So it went very well, I think.
Well, it's mostly good. I'm glad we got everything done that we needed to do, and I'm looking forward to coming home. But it's also a little bit sad every time a cruise is finished.
If we would have got the mooring from today back, it would have been perfect.
The 5 acoustic moorings will be recovered in September 2016, while the oceanographic moorings will be recovered in September 2015.
Well, it's not quite over till it's over. We still have to unload and get packed up and get ready to go, so there's another couple days' work.